trig equations. In trig equations, these are actually trig functions. And remember that a function means that for any given input, you have one and only one output. The problem is when you think about things like, trig functions, if I give you an input, there can be more than one output for the result. In other words, if I want to know, this is a cosine function graph and a cosine graph. If I want the inverse, meaning I'm going to make the y the input, an input of 0.5, the inverse cosine, well, that could be at this point or at this point and continuing on. Likewise, an inverse sine of 0 happens here and at pi and at 2 pi. The inverse function fails the horizontal line test. So the way that this is rectified is that we do it over a limited range. Okay? The range is limited. So, oops, where'd it go? Sine, we limit the range from -1 to +1. The cosine from -1 to +1. The tangent is all real numbers. But we also then limit our domain. Okay? We limit our domain when we're doing inverse so that we don't run into this problem. Now, what does that mean? That means, remember that when we did inverse trig function, we got a value. Now, when we solve trig equations, you might want more than one value. So, when you get more than one value, you got to ask yourself, over what range? Okay, now here, take a look. Going backwards, looking for the value of the angle measure. You're going to ask yourself between 0 and 2 pi, not including 2 pi because 0 and 2 pi are coterminal. Does the sine of theta equal a given value? I'm going to look at these problems here. So for this one, find theta if 0 is less than or equal to theta is less than 2 pi, given that sine of theta is equal to 1/2. Well, what I want to know is, where's the sine 1/2? Well, remember, we can do our quick, easy, boom, 1, 2, 3, 1, 2, 3, everybody over 2. And everybody wears a hat, except for 1, because 1 got to take it off. Root 3, 1, root 3 over 3. Pi over 6, pi over 4, pi over 3. We also have our pi over 2 up here. Okay? Now, I want to know, given sine is 1/2, remember that x is on the unit circle, x is your cosine, y is your sine. So sine is 1/2 right here at pi over 6. It's also positive in the second quadrant. So I'm going to have pi over 6, and in the second quadrant is 5 pi over 6. And we can check our answers. Boom. Okay, for number 2, I want to find theta if 0 is less than or equal to theta is less than 2 pi, and cosine is negative root 3 over 2. Well, first, I need to find the family. So cosine being root 3 over 2 is right here at pi over 6. But when it's negative, I'm in quadrants 2 and 3. So this should be 5 pi over 6 and 7 pi over 6. Now, moving on for number 3. 0 is less than or equal to theta is less than 2 pi. Tangent is 1. Well, tangent is 1 for pi over 4. Tangent is negative in quadrant 2. In quadrant 3, it's positive again. So this one will be pi over 4 and then 5 pi over 4. These are really just doing the inverse trig. Now, here's another one. Inverse sine is -1. Let's see if we can do this, just because I know it helps. We're going to copy this to this page. Oops. So we can refer to it. Okay. All right, if you want, you can pause the video and try these and then start it again, or you can just follow through. So I want to know where sine is -1. Well, remember up here it's 0, 1. Down here is 0, -1. The inverse sine of -1 is -pi/2, but I want between 0 and 2 pi, so I really want 3 pi/2. If it were the function, it would be -pi/2, but because I've changed where I want my answer to fall, it's 3 pi/2. Okay? The next one, cosine is 1. Cosine is 1 at 0. Okay? And at 2 pi, but we don't put 2 pi in. Why don't I include 2 pi? Because notice it's theta is less than, not less than or equal to. Make sure you pay attention to the range that you're given. Okay, here, secant is -2. Well, now I've got to figure out, if I take any of these and I flip them upside down, I realize it's my 1/2. Then I have to figure out secant theta is equal to 1 over cosine theta. So I'm looking for where the cosine was 1/2, which was here. I'm looking at -2, so that means I'm in quadrants 2 and 3. So I'm in quadrants 2 and 3, and I am the pi/3 family, which would give me 2 pi/3 and 4 pi/3. Okay. Notice everything comes down to which quadrant you're in and which family it is. Okay. Cotangent is -√3. So that's going to be the pi/6 family, because I got to flip this upside down. And where is tangent negative? In quadrants 2 and 4. So this is going to be pi/6 family in quadrants 2 and 4. So what are those values? Well, in quadrant 2, it's going to be 5 pi/6, and in quadrant 4, it's 11 pi/6. Okay, finally down here, sine is -√2 over 2. That's going to put me in quadrants 3 and 4. So this is quadrants 3 and 4, pi/4 family. So that's going to be 5 pi/4 and 7 pi/4. Okay, you got to get comfortable with going backwards and forwards on the unit circle. Suppose the question asks about 0 to 360. Well, just change all those radians into degrees. Remember that pi/6 is 30, pi/4 is 45, and pi/3 is 60. Okay? Now, solving a trig equation. It's really no different than solving algebraic equations. You're going to use algebraic techniques. You're going to exchange one trig function for another using identities, and you're never, ever going to divide by a trig function. We'll show you why. Okay, this first one, cosecant squared x minus 4 is equal to 0. I can solve this using square roots. First, I add 4 to both sides, and then I take the square root. So cosecant x winds up being equal to plus or minus 2. Now, what I have to figure out is, where is cosecant plus or minus 2? Well, cosecant is the reciprocal of sine. So where is sine 1/2? Good. Sine is 1/2 at pi over 6. And since this is every place around the circle, it's going to be all of them. Okay? Now, what if I wanted it with the 360? That's where I do the degrees. I'm not going to be asking you for degrees on your test. But notice, this is just using square roots. Okay, what if you have to solve 2x minus 1 equals 0? Well, that's easy. You add 1 to both sides, divide by 2. Boom. So now if I want to solve 2 sine x minus 1 equals 0, I'm going to proceed in the same manner. I'm going to add 1 and then divide by 2. But we're not quite there yet. I don't have x by itself. I have sine x. So what do I have to do? I have to do the inverse sine. So sine 1/2, if I look at a graph, here's the sine function. And we're going to get more into graphing in the last trig unit, but suffice to say the red is graphing. Then I take and I draw a horizontal line. And here is every place where sine is equal to 1/2. Notice there's a lot of places. Okay, well, it happens to be at pi over 6 and at 5 pi over 6. If I want to know every place, then what I'm going to do is say at this spot, and then if I go all the way around, what is all the way around? 2 pi. So I've got 2 pi plus pi over 6, but wait, can I go around just once? No, I can go around and around and around and around. So I'm going to have this number k. K is an integer. I can go forwards or backwards. It's any coterminal angle. This right here just says coterminal with whatever angle that is. So I do the same thing with 5 pi over 6, and now I can take care of anything. Okay? Most equations are going to limit you from 0 to 2 pi or 0 to 360. But always read the question carefully to determine the given domain. Okay? Sines and quadrants. If I want to solve sine x plus square root of 2 is equal to negative sine x from 0 to 2 pi. And notice I use brackets. That means inclusive. So that means if 0 is my answer, 2 pi will also be an answer. If I used a parenthesis, then 2 pi would not be an answer. So what do? I add sine x. Remember, don't divide. I add sine x to both sides, and I subtract the root 2, and I divide by 2. Now, hopefully root 2 over 2 looks familiar, and you know that's going to be your pi over 4 family. So I take a look at it, and I note this is going to be pi over 4 family. And in which quadrants? Well, sine is negative in quadrants 3 and 4. So quadrants 3 and 4. The root 2 over 2 is just my reference angle. So I come down here, and I get 5 pi over 4 and 7 pi over 4. If you wanted it in degrees, there's the degrees. Okay? Next up, another way to solve. We have 2 tangent x plus 2 root 3 equals 0. Subtract the 2 root 3, divide by 2. Tangent is negative root 3. Where is tangent negative? That's the first thing you can ask. That's quadrants 2 and 4. You want to figure out which family is it? Well, the family happens to be the 60 degree or the pi over 3 family. So here it's going to be 2 pi over 3, and here it's going to be 5 pi over 3. And again, I've given you the answers in both degrees and radians just so you can see them both. You notice that solving the equation, you're doing exactly what you would be doing in algebra. Okay? So, tan squared x minus 3, add 3. Now this one I only want to go from 0 to pi. So I wind up with tangent is equal to 3, or tangent squared is 3. Tangent is equal to plus or minus root 3. Well, what I have to figure out is, this means I want, all 4. I want all 4 quadrants, except that this says I don't want these 2 quadrants. So now what am I going to do? Well, tangent is equal to root 3. That's my pi over 3 family. So pi over 3 comes here. Over here, it's going to be 2 pi over 3. If I went all the way around, I would take these pi over 3 families as well. But I've got to pay attention to my restrictions here. Now, notice I've got tan x sine squared x is equal to 2 tan x. Remember what we said. We never divide by a trig function to solve. So, first thing I'm going to do is I'm going to subtract 2 tan x from both sides. Okay? Now I can factor. I factor out, I've got tangent x and tangent x. So I take out a greatest common factor. Now I have tangent x times sine squared minus 2 is equal to 0. Okay. At this point, I know that I can set tangent x equal to 0 or sine squared x minus 2 equal to 0. Over here, I get that sine squared is equal to 2, sine x is equal to plus or minus root 2. Square root of 2 is greater than 1. So, does not exist. Remember, sine can only be from 1 to negative, or from negative 1 to 1. So this won't give me an answer. So my only answer is going to come from tangent x. Tangent x can equal 0. Remember that tangent theta is equal to your y over your x. Where is y 0? Where is y 0? Well, y is 0 when we're at 0 or pi or 2 pi. And we include the 2 pi because it was asked for. Most of the time it will not be asked for. Okay? And if I look at a graph, notice here, here, and here. Okay? All right. Never divide by a trig function. Why? Well, in the example that we just worked through, if I were to have divided by the trig function, I would have divided tan x and tan x, wound up with just the sine squared x is equal to 2, or sine x was equal to plus or minus root 2. Since this is no solution, comes from this particular one, we lost the tan x term, which means we lost a solution. Not good. Okay, so why you could lose a solution. Now, what if it's a quadratic? Well, that means that you're going to have to factor and then set each factor equal to 0. So I've got 2 sine squared x plus sine x minus 1. Factor it. Set each factor to 0. Sine x is 1/2. Sine x is equal to negative 1. Where's sine half? It's at pi over 6 or 5 pi over 6. Where's it negative 1? At 3 pi over 2. And notice I gave 3 pi over 2 because it's in there. The function sine to the negative 1 equals, let me write that better. Sine to the negative 1 of negative 1 equals x. X would equal negative pi over 2 if I were doing just the inverse trig function. But because I'm solving an equation and I've been given a specific range, okay, for my answer to be in, I put my answer, I find the coterminal angle that is, I find angles that are coterminal to negative pi over 2 that fall within this range. Using identities. Well, now I've got 2 cosine squared x plus 3 sine x minus 3. Ooh, I got cosine squared and sine. In order to factor, I need everything to be the same trig function. Since they're not, I have to use my Pythagorean identity. I'm going to change cosine squared to 1 minus sine squared. Then I'll distribute the 2, and I have my new equation. Now, anytime you've got the squared function with a negative, divide everything through by a negative, which means, notice, every sign changes. Now I factor, and I solve, just like I solved the previous one. Okay? This one's still sine pi over 6, 5 pi over 6, and then 1 pi over 2. Okay, pause the video and take a look at it. This is doing the inverse trig. Okay? This is solving. When you get here, what you're doing then is you're doing x equals inverse sine of 1/2. Okay. Using quadratic formula with trig equations. Ooh, because what if something doesn't factor? Like this one. Okay, notice up here, first thing I did, I substituted in 1 minus sine squared and distributed the 3. Combined my like terms, multiplied by negative 1, and then I got this creature here that doesn't factor. Well, you can use the quadratic formula. But now what you've got to remember is that it's not x, it's sine theta. Sine theta, okay, is equal to negative 5 plus or minus square root of 25 minus 4 times 3 times 1, all over 2 times 3, and we get our answers. Now, notice, this is pretty ugly looking, right? This one over here, I get it down to sine of theta is equal to negative 1.4342. You should notice or recall that's not going to give me an answer because sine has to be greater than negative 1, less than or equal to 1. Over here, this is possible, but ooh, I don't recognize that. So how am I going to do that? I am going to take my calculator and I would take and do second sine, so I get the inverse sine, negative 0.2324, and press enter, and I get negative 0.2345. And notice this says, wrong thing. Well, if I want it in degrees, remember I had to change my mode to degrees. Now, oops, it's a pain in the butt to do this on the computer, but negative 0.2324, and I hit enter, negative 13.438. So the reference angle is 13 to the nearest degree, okay? I did this, 13 is the nearest degree. I want angles, between, what did it say, 0 and 360. So that means sine is negative in here and here. So this is going to be 180 plus 13 and 360 minus 13. That's where I get my 347 and my 193. Alrighty. If something is not on the unit circle, you will be able to use a calculator. So unit circle one, you've got to be able to do it without a calculator. Okay, the way the rest of this video is going to work, I'm going to tell you to pause and try to solve this one. And then I'm going to come back and reveal the answer. When the answer is revealed, you can then pause the video and take a look at it. Be sure to send questions or come and ask me questions in class or send me an email. Okay? Right. So for this one, yes, I distributed. Could you do it another way? Sure. I could have divided both sides by 2. And then subtracted 1. And notice I get to the same place. So it really doesn't matter which way you went. Now you simply have to take x is going to be equal to the inverse cosine of negative 1/2. And you wind up being 2 pi over 3 and 4 pi over 3. And again, pause the video and look at the work. Okay, next one up. Pause the video and try this one. And you're back. Okay, remember we're going to subtract the 2 tan theta. We subtract the 2. Take the inverse tangent of negative 1. This is just saying that tangent is less than 0 in quadrants 2 and 4. Again, we prefer our answers in radians. Okay, for this one, we're just going to subtract 3, divide by 2. Think about this. Cosine x is equal to negative 3/2. Oh, that should be a quick one. Why? Can cosine ever equal negative 1/2? No. So it has no solution. Okay? For this one, pause the video and try to solve it. Okay. 3 cosine x minus 3 equals 3 minus 4 cosine x. Add 4 cosine x to both sides. 7 cosine x. Add 3 cosine x equals 6/7. Well, it can, but guess what? It's not on the unit circle. So what are you going to have to do? You're going to have to use the calculator. And the calculator is going to come back and it's going to give you an angle of 31. But you need to remember that cosine is positive in quadrants 1 and 4. So how did I get 329? I did 360 minus 31. Okay? So again, this one, x is equal to the inverse cosine of 6/7. This is going to be, use the calculator. Calculator will give you approximately 31 degrees. So you've got one answer. Now you've got to use that answer to find your other answer. Okay, number 5. Pause the video and try this one. Okay, take a look. What do you see? Notice this one's not bad, and I've shown both ways. You can factor it, you can solve it by taking square roots or by factoring. Either way, you're going to get the entire pi over 6 family. Okay, ooh, what about this one? Are there any factors of -5 that will add up to -4? Pause the video and work it out. And again, instead of 0 to 360, do 0 to 2 pi. Okay? Were you successful? Well, actually, that's right. It was 0 to 360 because it's easier with degrees. Never mind. My bad. Most of what I give you and on your test is going to be no calculator. Okay? So sine x can be this. It's going to give you -12, but remember that quadrant 3 is going to be 180. I don't know why my pen decided to stop. (180 plus 12), and then quadrant 4 is 360 minus 12. Okay, let's try this one. Now remember, use the quadratic formula. Got it? How did you do? Okay, oftentimes when you wind up using the quadratic formula, either the plus or the minus one is not going to work. Okay, in this case, you wind up with cosine theta is equal to -0.8. You know that's going to happen in quadrants 2 and 3. The calculator will give you 151 degrees. You've got to get the 209. Right. Try this one. Ooh, tricky. Let's see if we can at least get a start on this. Notice that I've got cosine in the denominator. If I multiply this side by cosine x and this side by cosine x, I'm going to get 4 cosine squared x plus 3 cosine x is equal to 2. Cosine x's cancel. Then I'm going to subtract the 2. Now I can try factoring. If it factors, great. If it doesn't, quadratic formula. Pause the video and finish this one. Okay? Again, didn't factor, so you got to do it yourself. You wind up with cosine. Cosine is positive in quadrants 1 and 4. So you're going to get your angle of 65, and then you're going to do 360 minus 65. Okay, this one we can't do. When you get to pre-calc, you will be able to do this. You can, after you understand how to do a double angle identity. Right? I will uncover this so that if you choose to, you can pause the video and take a look, but it requires you to use the double angle identity over here so that you can get everything in terms of just theta, not 2 theta. Okay. Next up, try this one. Remember how we solved the other one? Get rid of that fraction. You're back? Great. Take a look here. We multiplied everything through by cotangent x. And then this one, we were able to factor. Over here, cotangent is equal to -1/2. Over here, cotangent is equal to 4. Now be real careful because tangent and cotangent can be more than 1. Okay? So, here too, these are also, while -1 looks like a unit circle value, or sorry, -1/2 looks like a unit circle value, it's not for cotangent. So you're going to have to use the calculator. But how are you going to do that? Remember that cotangent x is equal to 1 over tangent, x. So, this is here, right? Tangent x is equal to 1 divided by. So, I'm going to get 1 divided by tangent x is equal to -1/2, right? Go from there to figure out how you're going to put this into the calculator. You're going to have to use the inverse tangent. How would you do that? All right. 1 over tangent x is equal to -1 over 2. If I cross multiply, let's see. I'm just going to go through this the easiest way to work it all the way out. I'm going to get negative tangent x, cross multiplying, is equal to 2. Tan x is equal to -2. X is equal to the inverse tangent of -2. And use a similar process here. So tangent x is equal to 4. 1 over tangent x is equal to 4. If I multiply, 4 tan x is equal to 1. Tan x is equal to 1/4. X is equal to the inverse tangent of 1/4. Okay? And then you can do that in the calculator. All right, now you are a real trig wizard. Do some of the practice work. We're going to have the foldables. And I will tell you that pretty much everything on your test and quiz is going to be no calculator. All right, great job.